We are going to be talking about piecewise functions today and tomorrow. And as of right now, what's happening on Thursday? Okay, your test. So we got that coming up in 2 days. I'm actually kind of toying with the idea of pushing it back to Friday, because we do have piecewise functions on the exam, and we have today and tomorrow, which I believe is more than enough time, but I don't want to just run through for the sake of the test. So I'll see where we end up today, how far we get, what we still have left to do, and I'll definitely let you guys know when we come in tomorrow. So as of right now, it's still going to be on Thursday. Tomorrow, these are due, the focus activities. You only have 3. Remember, this is one of those rare opportunities where you have the opportunity to just get a very good grade. All you got to do is work the problem with me, keep up with those slips. And there are extra slips over in the little filing cabinet right there next to Marcus, okay, Monday through Friday, in case you've misplaced or maybe you weren't here, but typically I put those aside for you guys. Let's see. Oh, there was one other thing. This right here, now it's not too big of an issue. I calculated it right before you guys came in, and only 23% of the students in the class so far are failing. And the biggest reason that I'm seeing is because of the homework assignments. So it's not huge, but it's almost a quarter of the entire class. So I really want to encourage you, if you're not turning in your homework, if you have questions, please come see me. Let me help you. Every morning, 7:45 to 8:05, I'm here. But you may have heard they went ahead and gave these to all the teachers, their United Way homework passes. Okay, so they do cost $10, but it would be for a good donation, but you would immediately get a 100 on any homework grade you want. Okay, one that has already taken place or one that's upcoming. So if you are missing, and there are several people, like I said, who are missing several assignments, if this is something you'd like to do, I mean, it does cost $10. You'd be helping out a really great organization, helping yourself out at the same time. If anybody is interested, let me know. Andrea, you're interested?
Is there, well, yeah, but is there a limit to how many you're allowed to get?
I'm going to go ahead and start. I'm going to go ahead and start with just one per person, and then I believe we're selling these until November 5th. That's the date I remember. That seems like a long way off, so I'm probably not correct about that. But if we get closer, I'll go ahead and start selling another to the same individual. I'm sure the United Way would not.
Like if I pay extra to get like 5.
Well, if you get 5, then that would be $50.
I mean, I get 8.
She's like, I got money. I'll make it rain. Okay. But anyways, that is available. Also, one other thing, I'm going to go ahead and do this because I'm really, trying to encourage you guys to get the homework done. A lot of you are doing a great job, and I want you to keep it up. I'm just kind of worried about those folks who are not getting the homework in, because progress reports are already going out at the end of this week. You'll get them next Thursday, and then we only have 3 weeks left in the 6 weeks. The next couple of weeks are going to be short weeks because you have Monday off the next 2 weeks. So just kind of keep that in mind. But this right here, this is what I was going to give you as a homework assignment for the piecewise functions. This is the lesson that we're about to start. So if you don't want to go ahead and pay $10 for your United Way ticket to get a free homework pass, what you can do, if you were to work this and turn it in, I'll put this towards a missing assignment. No, it is not. It is the homework assignment on the current lesson. So it is not a crossword puzzle. I'm sorry. Yeah, yes.
How long are the tickets valid for?
I don't know. I'd have to read up on them. Like I said, I want to say that I read on the email November 5th, but I'm not 100% on that. Like I said, that seems like that's a long way off. You didn't pick one up on the way in? Huh, okay. Here you go, Nathan. Now, that's what we picked up yesterday. Those are our notes. This would be the assignment. So this assignment is just going to be for your own benefit. I would really encourage you to take a look at it. Maybe in the next day or so, we can go ahead and look at some of those together in preparation for the exam. But if you were to go ahead and work that and get it turned in to me this week, if you're missing a homework assignment, I'll go ahead and replace that assignment with this one. Okay, flat 100. Basically, I'm just looking for a participation grade. I'm just wanting to get you to do it. Oh, already got one? All right. Hey, well, get me out to class, and I'll go ahead and take care of that. Okay. And I'll go ahead and do one better. Let's say you're one of those students who you've already turned in all your homework assignments, you're not missing anything, so you're like, well, what's the incentive for me to go ahead and do the piecework functions assignment? Even though it's math and it would be totally awesome, right? Okay, let's say if you were to go ahead and do that this week, I'll give you extra points on your exam. Okay, so there is something for everybody, whether you do have a missing assignment or not. Yes, sir. You have your hand up. I did see you. I just wanted to make sure I finished. Okay, that was your question. Okay, so there we go. So, I mean, good opportunities if you want to take advantage of them. If you have any questions, let me know. So I will definitely see Marcus right at the end of class. And anybody else, okay, just let me know. Hey, Brandon. You sure? Yeah. Okay. All right, well, we're going to go ahead and get started. Like I said, we're going to get as far as we can today, and then depending on how far we get, I'll go ahead and look it over tonight. We may, as of right now, we're still going to test on Thursday. And what did I tell you about your test? Okay, 20-point curve. No, there is something else, though, probably better. You can use your notes, okay? So anything, I give you a skeleton notes, whatever you fill in, homework assignments, focus activities, all of those are good to go. Okay, so let's see what we got here. Piecewise functions are functions defined by different formulas for different intervals of the independent variable. Independent. Okay. Now, when we're talking x and y, which one's the independent? X is always the independent. Y is the dependent. We always say y is a function of x. Y depends on x. So typically this is how a piecewise function is going to look. You'll start with your normal function notation, whether it be f of x, g of x, whatever. And you're going to have quite a few different equations here. Typically 2 at a minimum, okay? But you could have 3 or 4. And then what follows is the domain for each of those specific functions. Each one has a specific area that he wants to live in on the grid. He doesn't want to take up the entire grid. He only wants to have his own little space. We call these guys the subdomains, okay, because each one is going to be different. All right, well, let me go ahead and give you an example. This is the most famous piecewise function that we have, the absolute value function, okay, denoted by those 2 long bars. Now, we know absolute value. That's the distance from what? 0. It just says we can't have a negative distance the way we think of things. Like if I were to throw a ball, it doesn't make sense to say I threw it negative 10 feet. Okay. Well, you're still throwing it a positive 10 feet, right? Well, okay, let me say this. Let's look on the number line. Let's say 0, 10, and negative 10. So how many units is 10 from 0? It's 10. Well, how many units is negative 10 from 0? See, it's still 10. So no matter the direction, we're still going to go ahead and count it as a positive. But now you're right. When we're talking about when we could get into physics or some other application problems, it's not so much that we say it's a negative length, but it tells us direction. So you're right on that aspect. Okay. So absolute value is really made up of 2 different graphs that we then go ahead and restrict because they want to live in a specific region of your coordinate plane. So here's how it looks. Absolute value is x. That's your linear parent, just y equals x. If x is greater than or equal to 0, that's the subdomain. So x can only exist for positive values of x and 0. Or it's the opposite of x if x is less than 0. Okay, so let me kind of take a step back for just a second because maybe that's causing a lot of people to be hesitant. When you're creating a piecewise function, essentially what you're going to create is a Frankenstein graph. You're going to take all these other graphs, whether it be a parabola, a straight line, could be radical, and you're going to take pieces of them. You're not going to take the whole graphs. You're going to take parts of them, and you're going to put them together to form one new graph. Well, that's why we call it a piecewise function. The pieces form a brand new function. When it comes to naming things in mathematics, we are not very creative. Okay, you're going to see that as we go along. But there you go. Hey, it's awesome. Hey, Brandon. Yes. Just less than, because see, we already have the equality on that one. See, we don't want equality on both because then that would overlap. See, one includes the value, the other doesn't, so it still remains a function. And that actually goes back, if we did include them both, then it would not be a function. Okay, so let's just think back to way back in Algebra 1 or even before when you started learning these. Like y equals x, that's just a straight line, right? That's your linear parent. So he looks like this. Okay, goes through the origin, has a slope of 1. This is y equals x. Okay, well, what did the negative do? It flipped it, yeah. The negative is responsible for a reflection. So it just flips this guy. So this right here is y equals negative x. Okay, see, these are the two functions that work together to create your absolute value. Now, when you see an absolute value graph, it always looks like what letter? Ooh. It looks like a V, right? It's always a V, whether it's skinny, fat, opening down, whatever. It's always a V. Well, here's the reason why. It's made of these two intersecting lines. See, y equals x and y equals negative x. But see, y equals x, he only wants to live at 0 or larger. Okay, so y equals x, he wants to live here. He only wants to exist on the right side of the graph. Where does negative x want to live? He wants to live on the left. Yeah, he wants to be everywhere that's a negative x, so over here. So knowing that, let me go ahead and take this off now. Okay, didn't mean to go that far. But see, the line y equals x, if he only wants to be 0 or positive, then I'm going to take off the portion that's not 0 or positive. Okay? And now negative x, remember, he only wants to exist in the negative region. So any part of the graph that has a positive x, I'm going to take that off. And see, what do you end up with? There's your v. This is how we actually get absolute value. It's really a piecewise function. It's created by intersecting lines that we then restrict because they only want to live in certain places. Okay? So let's run through these questions here. Is the function above continuous?
Yes.
Yes. You guys remember a really good way to think about this is if you can draw the graph without lifting your pencil off your paper, okay, that means it's going to be continuous. That's a really good rule of thumb. Now, it doesn't work in every situation, but it works in the vast majority of those. Okay, so that is continuous. Now, this is something we've been practicing. This is definitely something that's going to be on the test. Okay, Jalen, what would you say the domain for this function is? How wide is he? Remember, the domain is how wide. Yes. You're Jalen, right? Okay, I want to make sure I'm getting there. Okay. Okay, that's fine. Mm-hmm. So are there specific values where he stops and starts, or does it go forever? Yeah, so there's a turning point. So 0 is definitely included, but let me kind of break it down. How far left is he going to go? He's going to go forever. How far right? He's going to go forever. So if it helps you, maybe when you're trying to figure out the domain and range, draw an arrow for every direction this guy's going to go forever. And that will definitely help you out when you're creating these. So even though he's going up and to the left, he'll go forever left and forever up. Okay, same thing on the right. He's going up and to the right, so he goes forever right, and I've already got the up labeled. And he won't go down forever. Okay. So yeah, if he's going to go forever left and right, well then he's infinitely wide. How would I write that? Yeah, negative infinity to infinity. Now, what can we say for this one interval if that's the case? All reals. We can always say all reals. Okay. Now, when we're talking about the range, okay, I'm going to go ahead and set this up. Whoop, I shouldn't put those on there just yet. I got my comma. Well, see, I already know that he goes up forever. So I'm going to go ahead and put an infinity there because we always go from the smaller to the greatest. Left to right, bottom to top. Okay? So we start where? We start at 0. Now, We never ever include the infinity, so that does need a parentheses. But what do you think about that 0? Bracket, yeah. That 0 is definitely going to be part of the graph, so I'm going to put a bracket. You put a parentheses if he's not included. Okay. And then decreasing and increasing. What does this mean? This is when the y values are doing what? Yeah, where they're increasing. So basically you want to look for the parts that would have like a positive slope. And on decreasing, look for the regions where they would have a negative slope. Okay. But now we define where those are by using the x-axis. Okay. So where along the x-axis, let me erase this right here. Okay. So where along the x-axis does this graph increase? In the first quadrant. Okay, so horizontally, it starts at 0 and ends where? It doesn't. It keeps going, right? So he's going to continue to increase forever. Okay. So for increasing, we're going to say 0 to infinity. Now remember, increasing and decreasing, we're not concerned with brackets. Increasing and decreasing, we'll always put parentheses. But if you were to put the bracket, that's not wrong. Okay. I'm just not going to be looking for that. So where is he decreasing? Yeah, quadrant 2, negative infinity to 0. There we go. All right, so a little bit of review based on what we had. Okay. Now, I think what's going to be more beneficial for you guys is if we skip the next two. The next two are great examples of piecewise functions. We call those step functions. So we're going to make that the very last thing we do. I want to go ahead and work with piecewise functions today. So we'll come back and revisit these. Okay, probably tomorrow, maybe Thursday. We'll kind of see how that plays out. Okay, so let's take a look at this. Here's my piecewise function. It keeps popping up for some reason. Okay, so how many parts belong to this piecewise function? Okay, there are 3 of them, right? I have 3 equations. So the first one is an absolute value. Okay, now the next one just says 2. In fact, what does the graph y equals 2 look like? Yeah, it's just a horizontal line straight across. That's exactly right. So it's a linear function. Now this one, you probably will recognize it better as a linear function. That's your mx plus b. Even though they wrote it as b minus mx, I mean, the order itself doesn't matter. Okay, the coefficient of x is your slope. The constant is your y-intercept. So this one's linear as well. If I could write today, that'd be fantastic. Linear. Okay. So let me go ahead and do this very quickly. Let me get a grid, because I want to go ahead and show you here. Okay. Let's go ahead and break this up. Okay. Where does the absolute value want to be? What's his domain, his subdomain? He wants to be what? Something compared to 1. He wants to be less than 1. So let's say 1 is right here. Okay. This. Okay. So the absolute value, he wants to live here. He wants to live in this whole region less than 1. So that's what the subdomains are telling you. Well, where does that 2 linear function want to live? He wants to live between 1 and 3. Okay. So let's say this is 3 right here. So this will be our linear. Okay. All right. And then where does the other linear, the third one, want to live? Greater than or equal to 3. So I have my third linear right here. Okay. So imagine that I had all 3 of these graphs completed in the same grid. Okay. Well, for the absolute value, I'd want to cut him off right here at 1, because he only wants to be 1 or less. The linear function 2 in the middle, he only wants to exist between 1 and 3. So if 2 is right here, well, then you're just going to see a straight segment right there between 1 and 3. Okay. And then larger than 3, you'd want to see that other one. So you're only taking parts or pieces of those graphs. Okay. Now we'll actually graph our first one in just a second, but let's talk about some function notation. Okay. So we have my function. Okay. We got my three functions here, the domains on each. First thing I want is f of 12. What does it mean if I were to give you something like f of 12? What am I asking you to do? Yeah, plug it in. You're given a value of x. So f of 12 is the y value that corresponds when x is 12, right? So here's the thing. I want to take x equals 12, and I want to plug it in. But where do I plug it in? Do I plug it in for all three of them? Can anybody tell me, how do I know which one to use? Okay, what follows the function? What's that? That's exactly right. Lilybell is absolutely right. She says use these to figure out which function. You're not going to plug 12 into all of these. There's only going to be one of them that you're going to plug into. Okay, so is 12 less than 1? No, 12 isn't less than 1, so you're not going to plug it into that function. Is 12 between 1 and 3? No, so you're not going to plug it in there. But is 12 greater than 3? Yes. Okay. Find the interval that your x belongs to. That's the one you want to plug in. Okay. So I'm going to take this guy right here, and I'm going to replace x with the 12. 5 minus 1/2 times 12. So what's half of 12? 6. So 5 minus 6 will give me -1. There you go. That's your answer. The biggest idea there is just figuring out which function to plug into. Okay? Just find the interval, the domain your x belongs to. Okay? And I know what we're thinking. You know, we're in math class, so it's got to be our most fun class. So is that answer -1? It's negative fun. Negative fun. Sounds very similar to -1. Hey, let's do another example. Okay. I'll win you guys over yet. I have 9.5 more months to do so. So it's going to be a long, yeah, typical school year, about 10 months. The summers are shrinking. This is the earliest I think we've ever started school. Okay. If certain people have their way, the summers are going to go away altogether, and we'll be going school year round. That's the current idea. There are different ways, you know, and it depends on where you go. But one idea is we would go for a grading period, have a week off. Go for another 6-week grading period, have a week off. But also different parts of the country, like my wife is from Kansas, and instead of 6 weeks, they had 4 9 weeks. So they went for a grading period of 9 weeks, and they only had 4 for the year. So I mean, it's you know, different for different districts.
But in other districts, do they have it where their 6 weeks actually only has like 5 weeks in it, or their 6 weeks only?
Actually, in years past, yeah, you know, just because of the calendar, the 6 weeks, first and second 6 weeks have really only had 5. And I'm wondering if that's had a part in why we started early this year, because there's always a lot of people saying, well, it's not 6 weeks, it's 5 weeks. You know, this is my education we're talking about, so we want more time at school. I'm sure that's what you guys say, right?
Schools overseas have it where it's just school year round.
Yeah.
You get winter break and like.
Mm-hmm. In fact, just FYI, just in case anybody was known, does anybody know why we get the summers off? One very important reason. No. Air conditioning. Because way back in the day, a lot of buildings did not have air conditioning, and what happened during the summer?
Yeah.
It got extremely hot. So parents would start pulling their kids out because it was too hot to go, and so many kids got pulled out that they just said, okay, during these hot summer months, we're not going to have school. So actually, I'm kind of surprised that that never reverted back, because now, I mean, we have a, I don't want to say crappy, but we've got a semi-functioning AC to help us during these summer months. I'm going to go ahead and move on with math, because, you know, administrator may listen to this recording and say, hey, well, you know, what's going on here? Okay. So B, f of 2. F of 2. So what's the x value I want? 2. Okay, so is 2 less than 1? No, so I'm not going to plug it in there. Is 2 between 1 and 3? Yes. So see, all I have to do is find that interval, that subdomain that x belongs to. Genevieve.
What if, like, more than one of them work?
It is possible. It is possible for, like if I were to go ahead and plug in 1, because you're going to notice when we start looking at these graphs, where one graph stops, okay, vertically, you can have another point above or below it. That is very possible. So for each function, we're going to want to plug in that number. So it's very, very possible. Yes, that's a good point. Okay, but now why is this one different? Anybody know what's the answer for f of 2? Yeah, it's just 2. See, this one is actually pretty nice to us. There is no value of x to plug in. So if that's the case, well then you would just say 2. Okay. If there's an x, then we plug in and we simplify. Okay. What about f of negative 5? Does he belong to the absolute value or one of the linear functions? Absolute value, because negative 5 is less than 1. Okay, so I'm going to plug it into that first one. Negative 2, absolute value. So x plus 1, negative 5 plus 1, and that's it. Okay. So what's negative 5 plus 1? Negative 4. So negative 2, absolute value, negative 4. And what's the absolute value of negative 4? 4. Absolute value will always give you a positive. Times negative 2, negative 8. There you go. This is how you evaluate a piecewise function. Is there anybody who's not seeing how I'm getting these numbers? Anybody confused? Okay. Would you say it's a piece of cake? Because it's a piecewise function? Yeah. 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 Yep. Okay. All right. F of 0. To which function would 0 belong? Again, the first one, because 0 is less than 1. All right. So I'm going to go ahead and plug in again. Negative 2 times the absolute value, x plus 1, 0 plus 1. All right. So what would that become? Would simply be negative 2. That's it. There we go. Okay. Perfect, perfect, perfect. All right, moving on. Example 3, we have ourselves another piecewise function. This one only has 2 functions in it, though. What type of graph is 3x minus 7? That's linear. And what about x squared minus 1? Okay, that's going to be quadratic. Okay, Genevieve? Oh, okay. So let's start with A. I want to evaluate f of 6. So does 6 belong to the linear or the quadratic? Belongs to the linear because 6 is greater than 2, right? See, for the quadratic, we only want values less than or equal to 2. Okay, so look at those intervals. Those subdomains are going to tell you exactly what you need. All right, so we just go ahead and plug in. 3x minus 7. So 3 times 6 minus 7. And 18 minus 7, what am I looking at? 11. Okay, that's it. And, you know, we can go back and make a connection here because remember the value of x is 6, right? So because f of 6 gave me 11, I know that I should be able to find this point 6, 11 on one of those pieces, one of those branches. Just like in the previous one, f of 0 gave me negative 2. So I should have 0, negative 2 as a coordinate somewhere in the piecewise function. Okay. Let's try this one, f of negative 3. Where should the negative 3 go? Definitely the quadratic. Negative 3 is less than 2. Okay. So let's see here, x squared. So it's only x that I'm replacing. I'm going to say negative 3, and then I'm going to square it, minus 1. But what happens when you square a negative? Yeah, you're going to get a positive. So 9 minus 1? 8. Okay. So if I did want to locate this point on the graph, what would the actual coordinate be? Okay, negative 3 comma 8. Perfect. That's it. Anybody having trouble? How are we doing? Okay, yes, ma'am.
What if they give you like one of these and they don't go with none of these?
Now that's interesting. I've never seen one that doesn't. Everything that we're going to work with, it should fit somewhere. Okay. Right. So Nathan, what do you think? Good? All right. Okay, so let's see what we got here. So now here's the next section. It says write the piecewise function that represents the graph. Okay, so now I want to come up with the piecewise function given the sketch. All right, so you'll notice we can go from top to bottom. So 1, 2, 3, and then we go from left to right on the graph. So this is 1, this is 2, and this is 3, just so everything matches up nicely. Okay, we have it all in order. Now, how you want to do this, maybe you want to go ahead and figure out where these guys want to live, where their intervals are going to be, the subdomains. Maybe you want to go ahead and get the functions first. I think it might be easier to go ahead and get those intervals before we do anything else. Okay, so let's start with this graph right here. So pretend these guys don't exist. Just kind of put them out of your head. Okay, think about just what we've been doing with domain and range, but we're only interested in the domain. Where does this ray exist horizontally? Okay, so how far left will he go? He'll keep going forever to negative infinity. Okay, yeah, so that's an arrow. Okay, sorry about that. And as we're coming in, where does he stop? Okay, he wants to stop at 2. So that's the only place he wants to live. Anything less than 2. Now, typically, we're accustomed to putting these in interval notation, but when you're talking about a piecewise function, we actually prefer the inequalities. So I'm going to go ahead and say all x less than 2. Now, would I have equality? Would I say less than or equal to? Brandon says no. Why? Because it's an open circle. There we go. Okay. Now let's do the same thing for this horizontal one. So he's the second graph. He'll be the second row right here. So where does he want to live? From 2 to 5. So I'm going to write this as a compound inequality. We're looking for all x between 2 and 5, right? And remember, we brought this up before. Your expression should mimic what you see. We're looking for everything between these two boundaries. Okay, so I'm going to go ahead and put less than, less than. Now, the only question, will either one of those or both have equality? Which one? Find the 2. There you go. The 2 has a closed circle on it, but the 5 has an open circle, so I'm going to leave it strictly less than. Okay. And you see how these are flowing together? See, the previous one doesn't include the 2, but this next one does include the 2. And typically, that's how these functions are going to work. Wherever one stops is where the next one's going to pick right up. Not always, but typically they're going to stop and start on the same value. Okay. And let's try this last one right here. This ray that's pointing down and to the right. Where does he want to live? Where does he start? He starts at 5. And how far do we go? Forever, because we got this arrow, right? So as an inequality, I'm going to say x what? Needs to be greater than 5. Now, am I missing something? Y equality. He starts with a closed circle. That's exactly right. Okay. So that portion, we're already familiar with. That's something we got. Okay. Now what we want to do is go back and find an equation for each of these. Now, the fact that they're in pieces, don't let that bother you. Like this first one right here, imagine that it just kept going. See, we already have where he wants to live, but I want to write the equation of that full line. Okay, the equation is always going to be the exact function, but then the interval just tells you where he wants to live. Okay, so let's go ahead and do this. Yes, sir. So he says negative 2x plus 4. Okay, we're very close. Okay, now I do want to go ahead and put these in slope-intercept form. What's that? What's slope-intercept form? Y equals mx plus b. What's what? Oh, I was like, what are you doing? What? Must have hit it with my sleeve. There we go. Okay, so we want to put them in y equals mx plus b. And this is the easiest way to write the equation of a line. I only need 2 things. I need the slope m, and I need to know what the y-intercept is. Well, if I'm looking at this line, Do we already know something? Yeah. Where is he touching the y-axis? 5. Ew. So I know that it has to be plus 5, right? Well, what's the slope of a line that drops to the right? Is it positive, negative, 0, or undefined? It's negative. So I know it has to be a negative. But now, as far as finding the slope, that's completely up to you. What I like to do if I'm given a graph, I like to go ahead and choose 2 points, 2 perfect points of intersection where a vertical and a horizontal line on your grid cross. We call those lattice points. Okay. So all you got to do is rise over run. So I want to get from here, the first point, to the second point. So how far down did I have to go? 1. How far to the right? 2. So I know my slope has to be negative 1/2. So 1/2 x plus 5. Now, if you want to go ahead and use the formula, this point right here is 0, 5. Take this point right here. Even though it's an open circle, it would still be a point on the line, right? What's that coordinate right there? 2, 4. What's the formula for slope? The change in y over the change in x. Yes. So subtract the y's. Okay. So 5 minus 4 over. Now, once you choose a direction, you have to go in the same direction. See, I went 5 minus 4, so I have to go 0 minus 2. So let's see, 5 minus 4 is 1, 0 minus 2 is negative 2. See, I still get negative 1/2. So if you want to use the graph and just say rise over run, if you want to go ahead and use the slope formula, whatever you want. Okay, that's completely up to you. All right. So I've got that first one done. Okay. So now let's go ahead and take a look at the second one. Now this one is probably the easiest of the 3. So imagine he just goes forever, a horizontal line. Okay. Okay. It's 3. It's crossing at 3. That's it. That's it. The equation of a horizontal line is always y equals. What's the equation of a vertical line? X equals. There you go. So if it's a horizontal or a vertical part to the graph, it's easy to figure out. Okay. Anybody having trouble? Okay. And let's go ahead and take care of this one right here. Now let's see, it doesn't cross the y-axis like the other one did. Okay, so I don't immediately know what it is, but let's choose a couple of points. Like this point right here, that's a perfect one. Maybe this point right here. Okay, and you'll notice there is another one, but I'm just trying to show you something. So let's at least go ahead and find the slope. Okay, how far down am I going? In order to get even, I got to go down 2 and then right 2. So this is 2 over 2, right? But there's something I'm forgetting. Why negative? Because the line is dropping to the right. So actually, what's my slope? Okay, so negative x. So it's just negative 1. So I'm going to say negative x. And you know, that coefficient 1, if you want to go ahead and put that, you can. But typically, you know, 1, we don't go ahead and write. That's just understood. Okay. Now, you can go ahead and use the equation to kind of work backwards, but let me show you a pretty cool trick. Now, this won't always work. But remember, what's my slope? We said it was a negative what? Negative 1, right? So from this point, if I went down 1, right 1, down 1, right 1, I'm always going to end up on the line. Well, why don't we just go ahead and reverse that? Instead of going down and to the right, go up, left. Up, left, up, left, up, left, up, left. It's crossing at 7. Now, depending on your grid, that may not always work. Okay. Let me go ahead and show you the algebra way just in case that doesn't happen. Because it's very possible that your y-intercept could be well off your grid, right? You don't even see it. Okay. But I'll tell you what, I've got 33. Why don't we go ahead and stop there for today? Okay, I've only got about 2-3 minutes left. What do you guys think? How are we doing? Not bad? Okay. All right, now, don't forget. Oh, yes, ma'am. Yes. All right. And anybody else need the key from the homework assignments? Okay. So when you're done, man, would you go ahead and give it to him? There you go. All right, so don't forget, this that I gave you right here, this says Piecewise function homework, that can either do one of two things. It can either replace a missing homework grade or do what? Or give you points on your exam, okay, at the end of this week. And if anybody's interested, I got one already. If anybody wants to purchase one of these United Way homework passes, they are $10. I know that's a lot of money, but you'll be helping out a lot of folks. And you'll also be getting a little help for yourself at the same time. So it's win-win. Okay. So let me go ahead and shut this down.